Welcome to today's session. If you will look in your November 29th folder on Schoology, here are the things that you will need for today's assignment. So when you open the session 3 and 4 from lesson 16, those are our slides that you will complete. If you're in person, there's paper, and you will complete this on paper. But what you're going to do is open this up. When you open it up, you will see the first slide that looks like this. And today we are continuing on with unit rates. We're going to be using unit rates to compare ratios. So this will finish up lesson 16. The very first thing you're going to do after you open this is go back to Schoology. Look in the November 29th folder. Complete the rates and unit rates ed puzzle. You might want a piece of scratch paper. When you finish, you can go ahead and begin working on today's pages. So that ed puzzle is right here, the very first thing on your list of assignments. All right, so if you've opened this, great, leave it open. Go do this ed puzzle. It's just a quick review of what we've done so far with with rates and unit rates, so that you can kind of jog your memory a little bit there. So complete the ed puzzle, then continue on with today's pages. Alright, Antonio uses dish soap in his recipe for giant bubbles. He compares the prices of two brands of dish soap. Which brand is the better buy? So they give us both brands over here, brand A and brand B. And these are rates right now. Currently, this ratio is set at a rate of 32 fluid ounces for every $2.56. And then brand B is 48 fluid ounces for every $4.80. So you want to see which brand is the better buy. So there's two ways to look at this. So when we talked about rates before, we talked about how all rates have two unit rates. And we did some tables similar to this. So we would have had ounces for every dollar. Right? So brand A is 32 for every $2.56. Right? And then from there, you would have said, okay, you can figure out per ounce, right? Or you can figure out how many ounces per dollar. So what this one is going to tell you, if you figure out how many dollars per ounce, you want to look for the one that's the lower price, because that would be the better buy. If you're figuring out this unit rate, how many ounces per dollar, you want more ounces for every $1. So you would be looking for the greatest amount of ounces per dollar. So you can do it either way. You can choose and go ahead and find your rate if you remember how to do that. If not, hang on a minute. We'll go over it. All right. Before we go over it, if you look at the next slide, it does work it out both ways for you. It's a notes page that your curriculum has for this. So I am going to go on to that page to discuss how to work these out. All right. Okay. So for this one, the very first one they did, they found ounces. They found dollars per ounce. So they set up their initial ratio. They had price per ounces, right? So the initial rate was $2.56 for every 32 ounces. And they want to know how much does it cost for every 1 ounce. So to do that, you can take your $2.56 and divide it by 32. Because what they did was they looked at this and they said, okay, how do you get from 32 to 1? We talked about many times last week how any number divided by itself is 1, right? So divide by 32. If you do that to one part of your ratio, you have to do it to the other part of your ratio. So that's where that came from. And we did work them this way last week. So $2.56 divided by 32 is going to give you this, right? It will give you 8 cents. Then brand B, they set up the table in the same way. Price per fluid ounce. So we have $4.80 for every 48 ounces, but they want to know for every 1 ounce, right? And then they had this as their missing piece. So how do they get from 48 to 1? Well, we divide by 48, right? Any number divided by itself is 1. If you do this to one part of your ratio, you have to do it to the other parts. They did it to fluid ounces, which means they have to do it to the price. So $4.80 divided by 48. And that will give you 10 cents. Okay? So 8 cents for every ounce or 10 cents for every 1 ounce. Which one is going to be your better buy? All right? The second way they worked it is the way I probably would have done it. So fluid ounces per dollar. So the brand A is 32 ounces for every $2.56. And I would want to know for every dollar, how much am I getting? So the relationship is here. Divide by $2.56, right? If you do that to the one part of the ratio, you have to do that to the other part of the ratio. And then same thing over here. $4.80. That's what we would be dividing by here, right? And then we get this. So that is how you would use tables similar to what we did last week. Now, that's fine. It's perfectly fine to do it that way, all right? I probably wouldn't set these up as tables. So what I would do instead, I would set them up as fractions and then divide. So what I mean by that is 32 ounces for every $2.56. When you divide that, you get 12 and 5/10 ounces for every dollar. Right? Then I would set up brand B the same way. 48 ounces for every $4.80. Divide, right? Once you finish dividing, you'd get 10 ounces. So this tells me that I get more soap per dollar with brand A. So that's if you did it per dollar. Let's say that you did it per ounce. So if I did this per ounce, then I would have to swap. I have to do dollars per ounce, right? So $2.56 for every 32 ounces. That's my rate. But I want for every 1 ounce. When you divide that, I believe it should be 8 cents per ounce, right? Then you set up B, dollars per ounce. Right now, it is $4.80 for every 48 ounces. That's the rate. Our unit rate for every ounce. You are going to pay 10 cents. So in this case, we're not looking for the one that has more. We want the one that has less. We want to pay less per ounce, right? So this would still be our better buy. So that is how I am recommending that you set these up, is as fractions and then complete your division. All right. Again, that was your notes page. So let's look at one where we're going to have to do some conversion with measurement. So I told you before Thanksgiving break that we would be looking at some problems like this. So here it is. A band marches in the African American Day Parade in New York City. The band marches 800 meters every 15 minutes. At this rate, how many kilometers does the band march in 1 hour? So right now, 80 meters every 15 minutes. So we want to convert this. Right now we've got meters per minute, but they want kilometers per hour, right? So if you remember conversions from 5th grade, when you did measurement conversions, then you might remember that there's 1,000 meters in a kilometer, which means because we're dealing with numbers with 0, we have powers of 10, so we can just move our decimal point. We don't have to actually divide these. We could, if you want to. You could say 800 divided by 1,000, right? You could do that. You don't have to. You can just move your decimal 1, 2, 3 places because there's 3 zeros in the number 1,000. So now you have a decimal point here. So we have 8/10 kilometers every. Now we need hour, right? Well, we've got to figure out how much of an hour is 15 minutes. So this one for me would be more visual. You can know that there's 60 minutes in an hour and divide if you want to. But for me, I know that 2 15-minute periods is half an hour, right? Well, one side of my circle has to match the other, so that's fourths. So 15 is 1/4 of an hour. Okay, because that's 1/4 of an hour, I know that the decimal that matches that is 25 hundredths. So that's what I would go with. Which means I can now divide. So this is a fluency standard. You're going to set it up 8/10 divided by 25 hundredths, right? So I would prefer that you do the division on your own and then come back to the video to check it out and make sure you did it correctly. You cannot have decimal place values in your divisors. So you have to move this over 2 places, which means you do the same thing over here. 1, 2 places. Puts my decimal point there. There we go. Have to add a 0 there. So 80 divided by 25 is what I've got right now. So I can count by 25s in my head. So I know 25, 125 is 25, 2 25s is 50, 3 25s is 75. So that's pretty close, right? So let's stick with that one. 75. So 80 minus 75 is going to be 5, right? I can add a 0, bring it down. 50. two 25s is 50, right? So subtract 50. 50 minus 50 is 0. So 3 and 2/10 kilometers per hour. So now I know how far the marching band travels per hour. And there are other ways to work that problem. Get the answer. All right, so here are two different ways. All right, so we have two different rates. All right, the first thing they did was they converted here. They converted their meters to kilometers, and they did it with a chart. You can do that, okay? You could sit here and you can go 1 kilometer is 1,000 meters, which means 1 meter is this, which means 800 meters would be this, right? Doing all of these relationships, divide by 1,000 times 800, all right? Or you could convert the way that I did before. And then they converted their 60 minutes to an hour, 60 minutes and 1 hour. We have 15 minutes. So how much of an hour is that? It's a fourth of an hour, right? So the marching band, or the band marches 8/10 kilometers in 1/4 of an hour. So the left is a fraction, which is fine. But then, okay, so I don't like how they did this. There's not a lot of explanation here. So on my notes page, I would add this, all right? So what they're saying is you would have this, which that reads, this is 8/10 divided by 1/4, right? So when we multiply fractions, we keep change, flip. All right, so that's where this comes from. Or you could just know, you might look at it this way as well. So let me clear this. You can also look at it as if you have 8/10 for every 1/4, right? You can multiply by the reciprocal on the bottom. Whatever you do to the bottom of a fraction, you have to do to the top. 4/1. So you could look at it that way as well. Different ways to look at it, but that's how they get this. All right. So yes, you can multiply 4 times that, which will give you what you need to know, right? 8 times 4 is 32. And there's one decimal place value in this, so 3 2/10. You can multiply by a unit rate to convert between units of measurement. Write the rate for kilometers per meter. 1 kilometer equals 1,000 meters, right? So 1,000, or 1/1,000th kilometers per meter. So they took this, wrote it as a fraction. 1 kilometer per 1,000 meters. And then it says find the number of meters the band marches in 1 hour. So 15 minutes, 4 15-minute periods in an hour, right? So 4 times 800, which was your original rate, right, is 3,200. And then convert 3,200 meters to kilometers, multiplying by that unit rate with the kilometers to meters. So lots of different strategies, lots of different ways to work the problem. Um, as long as you still get to that same answer, then it's all good, right? So if we actually finish this out for them, we have 3,200 top being divided by 1,000. All right. You could think of it as simplifying it, dividing it, whatever. But when you finish that out, it would be 3 2/10. Again, we're working when you're dividing with numbers that are one digit and then a bunch of zeros, a power of 10 like that, you can just move your decimal point. That's 3 decimal place values. So I would move my decimal point 3 times in my number for 3 2/10. So you could work it this way. You could work it this way. You could work it the way I showed you before. Different strategies. Notice that either way, we're still getting 3 2/10, right? So you can convert everything first, right? And find your answer or solution. Or you can get a rate with your conversion or a unit rate with your conversion, and then go ahead and multiply, and then um, the next step here. So, by the way, this one, not my favorite way of doing this, but if you see it and it makes sense to you, go for it. All right. We are going to apply what we've learned. All right. So we did a problem that reviewed what we did basically last week, or not last week, before Thanksgiving break, right? And then we did a new problem where we had to convert some measurements, right? So, number one, the table shows the top running speeds for a giraffe and a zebra. Which animal can run faster? Show your work. All right. Giraffe, zebra, meters per second, meters per second. All right. We don't have to convert anything here. Yay. Um, so, we want to know which one runs faster. Now, we can find different rates, right? We could do meters per second, seconds per meter. Um, I'm going to do meters per second. All right. So for the giraffe, we have 280 meters for every 20 seconds. Let's see how fast this giraffe is running for every 1 second. All right. So to do that, you may already see what we need to do. You may not. This is a 1, by the way. So we want to do 280 divided by 20. 28 divided by 20 is going to be 1 minus 20 is with 8. Bring down the 0. 4. 4 times 20 is 80. Right? So 14 meters per second. Then we have the zebra. 204 meters for every 12 seconds. That's the rate that they gave us. So we want to know per second. So we can take 204 divide by 12. Right? 12 times 2 is 24. That's not what I want. So we just do 1. Okay. minus 12. It's supposed to be a 2, guys. Alright. We want to borrow. This would be a 1, that'd be an 8. Or not an 8, a 10. 10 minus 2 is 8. Bring down your 4. So we've got 84. Well, maybe. We can come over here. And we can say, alright, 12 times. Let's do 12 times 8, right? 8 times 2 is 16. 6. Carry the 1. 8 times 1 is 8 plus 1 more is 96, right? And remember, you only have to do this if you don't know your 12s. If you know your 12s, you already know what you're doing, right? 7 times 4 is 14. 4, regroup your 1. 7 times 1 is 7 plus 1 more is 84. So we have 17. 17 meters per second. There should not be a decimal point there. That was a slip up. So 17 meters per second or 14 meters per second. Which one is faster? And you're going to write your answer right here on this line. Make sure that you show all of your work. Alright. Number 2. 4 friends make chili for a chili cook-off. Each of them uses a different amount of hot sauce to make the chili spicy. Which ratio of hot sauce to chili makes the spiciest chili? So, whatever rate you find, you want it to be the same for all of them. So, hot sauce per 1 pint of chili. Let's see what this one is. So this one would be hot sauce, 15 to 6, right, to chili. Let's see what this reduces to. 3 is a factor here for each, so 5, 2, right? 5 divided by 2 would be 2, minus 4 is 1, so 2 and 1/2. 18 per 15, right? Let's see. 3 again, right? 6, 5. So that's equal to 1 and 1/5. And let's see, 12 to 8. So, 4, 3, 2, 1 and 1/2. And then 24 tenths to 12 fifths. That is equal to 2 fifths. So now we've just got to decide which one has the most hot sauce. Well, we know B and C are out, right? They are 1 and something. So now we're looking between A and D. 2.5. 2 and 2 fifths. Well, half of 5 would be 2.5, right? So it's just under half. Whereas this one is half. So A is our hottest. or spices. Chili has most hot sauce. Alright. The unit of money in England is the pound. When Anne visits England, 10 pounds equals $13. She sees a bike rental that costs £3 per hour. Anne wants to spend less than $20. Can Anne rent the bike for 5 hours? So, multi-steps here. We have pounds per dollar. 10 pounds for every $13, right? She sees a bike rental that's £3. Oh, wait. And it's £3 per hour. Okay, so 10 pounds is $13. She wants to spend less than 20, right? So let's see how many pounds she gets for $1. Let's check that out. So how many pounds for every $1? £10, $13. So 10 divided by 13. Sorry, I don't know why I did that. 10 divided by 13. Alright, so you can divide that if you would like to. It's not going to be what we call a nice decimal. It's just going to keep going and going and going and going and going. So decimals are not the best way to go with this. Instead, I would leave it as a fraction. So you've got 10 thirteenths for every dollar. And she's got $20. Relationship here is to multiply, right, to get from 1 to 20. Same over here. So let's multiply that times 20. So we have 200 over 13. So if you did that, you're going to get another big long decimal number, right? However, you will notice that 13 does go into 215 whole times, and you'll have some left over. 15 times 13 is 195, which means you had 5 left over. So that is how many pounds it's going to cost her. Well, that's how many pounds she can get for $20, all right? And she wants to spend less than that. And it's $3 per 1 hour. So if it's $3, not $3, £3 per 1 hour, that's what this is right here, right? Then we can see that I know that 3 times 5 is 15, right? So if she goes 5 hours, which is what she's wanting to do, right? She's wanting to earn it for 5 hours. 5 times 3 is 15. Well, she would have 15 pounds with her money. So, yes, she can do that. And then she'd have like 5/13ths of a pound left over, right? So, again, 3 pounds per hour. She wants 5 hours. Times 5. Times 5. 15. So it's going to cost her 15 pounds for 5 hours. Well, if she has $20, right? $20 will get her a little more than 15 pounds. So yes, she can spend less than $20 to bike. Not much, but yeah, a little bit. All right. Number 4. A can contains 4 cups of pineapple juice. The can of juice costs $2.56. What is the unit price in dollars per fluid ounce? Okay. So now we've got a measurement conversion. So if we have cups and we're wanting ounces, right? We've got to figure out how many cups are in an ounce or ounces in a cup, right? So there are 4 cups in every 8 ounces. So if we know that, then we know that we can go ahead and convert that. So 4 cups, right? And 8 cups equals 1 ounce. So if I multiply times 8, I will get 32 ounces. Then a can of juice costs $2.56. What is the unit price in dollars per fluid ounce? Dollars per ounce. So right now we have $2.56 for 32 ounces. So we want to divide that. So division is a fluency standard. I would like for you to try that one out on your own and then come back to the video. But you're going to take $2.56 and divide it by 32. So $2.56 divided by 32. Now these matter. These zeros matter because you are dealing with money and decimals and place values in front of your value. So those zeros matter. So let's try 32 times 8. 8 times 2 is 16, so 6 carry the 1. 8 times 3 is 24, plus 1 more is 25. Awesome. So we are multiplying by 8. We subtract, get our 0 there, nothing else to do. So 8 cents per fluid ounce. Make sure you show your work. So for this one, I converted my measurement first and then went from there. Remember from earlier in our lesson, there's different ways that you can work that, so that's completely up to you. All right. This one, I would like for you to complete on your own. It says a model train takes 10 seconds to travel along a section of track that is 5 yards long. At this rate, how many feet does the model train travel every minute? So, 10 seconds for 5 yards, right? And they're wanting to know how many feet per minute. So you can convert first or not convert first. But I will tell you the original way I wrote this, I would want to flip it around. I would want 5 yards for every 10 seconds. And then I would want to figure out how many yards are in a foot, all right? Or how many feet are in a yard, whichever way you want to think of that one. And then how many seconds are in a minute. So if we don't know, there's 3 feet in 1 yard. And then there are 60 seconds in 1 minute. Right? And we want to convert. And you can convert using ratios. Got 5 yards, right? So to get from yards to yards, times 5, times 5. 15 feet. Same thing with our seconds. We've got 10 seconds, right? So we would be saying 10 divided by 60. Which could reduce to 1/6. 1/6 minutes. So we can continue on from there. So I don't want to go over too much of how to do the problem, but this is one way to work it, to convert first, and then once you have your conversion, figure out your rate from there. Or you can work it differently. Remember, go back, look at your notes, look at what we've done previously in this lesson. Especially look at that example problem where it showed converting to find the answer in a couple of different ways. All right, so look back at that second problem that we did at the beginning of the lesson. It's very similar to this. Same method, different numbers. All right, so try your best on it. If you have questions, please ask. And I will see you guys for our next session.